Hello students, welcome back to physics sessions. Today we are going to discuss cases of the circular motion. So it will come under the laws of motion only. So the cause of circular motion is the centripetal force. Now we are going to discuss that effect of forces in different situations. Students, you can download the Spark Academy app and you can join us for free live classes daily. There are free daily live classes, in-session doubt clarifications, free material in our app, tips and tricks. Previous year's questions will be included. Admissions are open right now. So for short-term crash course and regular batches, students, in a week, my sessions will be on Tuesday and Friday. In a week, physics sessions will be 2 days on Tuesday and Friday. So be in contact for the regular updates. Myself, Sandhya. Today, I would like to discuss the cases of circular motion. Means I will be helping you solve the concepts of Eamcet, Neet, and JEE numericals. Students, if you are buying any course from the Spark Academy app, you can use the coupon code SAN10. By using this, you will get the 10% discount in that course, and you will be supporting me by using this. So let us go to our session plan. Today we are going to discuss the cases of circular motion. In that, first one is motion in a vertical circle. Next one is conical pendulum. Conical pendulum, which describes the horizontal circular motion. It describes horizontal circular motion. Next, car in a circular motion, that two different cases. Case of a car on a level road, it is in the circular path only. The path is leveled, means it is not, means the level of the road is flat. Next case of banking of road, frictionless, means smooth surface. Banked road means the outer surface of the road is a little up than the inner surface, like this. So the vehicles, these type of motion we can observe at the hill stations. So the banking of roads. Next, case of banking of road with friction. So these are the cases of circular motion. Here, our concept is vertical circular motion. You can observe in the diagram. Let it be center O. Now the string is attached to the bob. Let us see here. This is the bob of mass M. It is hanged from the fixed support. It is about its fixed point O. At this point, treat that point A is the reference line. Means at the bottom of the circle, means when the string is reeling in a circle, it makes the vertical circular motion. At the bottom, it is given with the velocity k, and when it reaches to point B, and one more thing, if we take in its journey at any point, for example, at this point. So I want to find the velocity at this point, and you must draw the component of forces at that point What are the forces acting when the bob is at a point P in its journey? Now the string is making a vertical circular motion. At bottom A, it is given with the speed VA. Now I want the velocity at point B. So for that, we are just drawing the component of forces. At point B, weight will act downwards. By extending this, it makes an angle theta with that vertical. Because here angle is theta, these two angles will be equal. This component will be mg cos theta. And now, so towards the bottom side, there will be mg sin theta. Okay, we just visualize the forces at a point P in its journey, in its vertical circle motion. So to find the velocity, let me write here. I'm writing down, you can observe. Velocity at point P. Initially, at point A, it is given with the speed VA. Now I want velocity at point A. So here we are going to use the law of conservation of energy. So to find the velocity at that particular point means total energy at point A will be equal to total energy at point P. So total energy, what is total energy at point A? It is on the like reference lines. Reference line means it is at the bottom, means no height, no position. On the reference lines, there is no position. When it reached to certain height at point P, so it can have the position. So at A, it is having only kinetic energy, no potential energy 0. So kinetic energy at the bottom line is half m VA square will be equal to. Now the total energy at point P. So it is at certain height h, like we can take. So from the bottom line to till here it is having certain height h. So mgh plus half m v t square. Means students, you can observe the diagram clearly, or I will draw separate diagram here, you can see, for finding velocity. So this is center. Now at this point it is given with the velocity A. Now it is at point P. So we have drawn the component of forces. Velocity direction is tangential at that point. So it reaches this much height, which is equal to this height. So this height can be given as, like you can consider this point is O, this point is C, and consider this point is P only. So OCP triangle, we can write it as H is equal to, means this total is R actually, this will be R minus H and this is R. So from OCP, H will be equal to R into 1 minus cos theta. Now, see, I'm explaining first what will be the velocity, then we go to the tension at different positions. So I'm writing up the main equation, velocity at any point in its vertical circular motion. So velocity at a point P. So if you simplify this equation, we will get it as under root of VA square minus like 2G H. We can write it as VA square. H can be written as R into 1 minus cos theta. So it is minus 2G into R into 1 minus cos theta. This is the main equation to find the velocity at any point. Here R is nothing but length of the string. So this is total is R. The R is nothing but length of the string. Now we consider tension first. We got velocity at any point in its journey. With this equation we can find. Now let us see tension at the lowest point A. We can see this is the lowest point. Tension at the point, it is acting normal to the reference line and towards the center, weight acting downwards. So tension it experiences towards the center centripetal force, that is mv square by r, where r equal to L. So at the point A, we can write tension at point A is equal to mv square by r plus mg. At that point, velocity is va, so mva square by L, where r equal to L. Since centripetal force is equal to mv square by r. Okay. Now we are taking the bob reaches to point C, which is at the top. We can see here weight of the bob and tension both will act towards the center. So T plus mg will be equal to mv square by r. So we can write tension at the topmost point, that is at C, mv square by r minus mg. Because T plus mg is mv square by r, then tension can be written as mv square by r minus mg. And the speed at that point, by using this equation, speed at that point, at point C, which is the top of the circular motion, can be written as mva square by L minus 5 mg. Because at the topmost point, theta is 180 from reference to top line. Theta is 180. Here to here, theta will be 180. When you substitute theta as 180 here, we get VA square minus 4GR. That value, if you substitute here, we will get it as MVA square by L minus 5mg, because by simplifying, we get this much. Next, tension at point C means from reference line to horizontal position. So now it makes angle 90 here. From reference to point B, angle will be 90. So you put here 90, cos 90, 0. So velocity at point B will be equal to VA square minus 2GR. But we need the tension. So at this point, tension and weight will be perpendicular to each other. So now we can write tension, the only force towards the center at point B is tension, and it experiences the centripetal force form, that is mv square by r. It is at B, so mvb square by r, where r is equal to L. So this is the tension at point B. Again we substitute velocity at point B will be equal to VA square minus 2GR. So as per that, it becomes tension at point B will be equal to mva square by L minus 2mg. And now you just subtract tension at point A minus tension at point C is equal to 6 mg. And now tension at point A minus tension at point B. These two, simplifying this one and this one, will give us cmg. So tension between reference to topmost point, tension along the string is being equal to 6 mg, and between reference line to horizontal position, that is B, it is being equal to 3 mg. And by comparing these equations, tension at the bottom of the circle is maximum, TA is greater than, TB is greater than TC. So at the topmost point, tension is minimum. TC is the tension at the top of the circle. TA is the tension at the bottom of the circle. Now, critical velocity, which is the minimum velocity at which the circular motion is possible. So, what is the minimum velocity required at that particular point? Then the bob will continue its circular motion. So, that minimum velocity required is the critical velocity. See here, critical velocity we represent with Vc. So, what is minimum velocity required at A? Root 5gl. Means at bottom, it required 5gl. Next, minimum velocity. This can be solved by applying the law of conservation of energy at the bottom. Means by taking conservation of energy between A and B that way. How I have solved here to find velocity at point B, the same thing, we get this result. Velocity, minimum velocity at C is required to continue further motion is root GL. Since at C, put T is equal to 0, means take this equation, put T value 0, this value 0. Then we get here. Here we need to put T value 0. Then we get velocity at C will be equal to like root GL. Next, velocity at B. Means for everything we can use this equation here. Velocity at B will be equal to VA square. VA we already got 5GL minus 2GR will come. Nothing but 2GL. 5GL minus 2GL we get 3GL. So at A minimum velocity required 5GL. At C minimum velocity required root 2GL. At B minimum velocity required root 3GL. So in the case of a critical velocity, so tension at point A will be equal to 6 mg because tension at point C is minimum. So we put TC value 0, TA is 6 mg. Tension at point C is always minimum, means at the top of the circle tension will be minimum, and tension at point B will be equal to 3 mg, because you can check here. If TA is 6 mg, take 3 mg this side, that gives TB value 6 minus 3, 3 mg. So in a vertical circular motion, to find velocity at any point, we have used the concept law of conservation of energy, and this is the main equation. So as per the angle at different situations, you can find the velocity, and these are the tensions in its journey, and these are the minimum velocities required to continue further motion, and these are the tensional force acting along the string or normal force acting along the string in different situations. So this is about vertical circular motion. And let us remember some facts about the vertical circular motion. If the body will complete the vertical circle, if its velocity at the lowest point is equal to or greater than 5 gr. So let the body continue in its vertical circle, it should maintain this much velocity. So to continue in the loop, it requires this much minimum velocity. Can be equal or greater. Then only it will continue the loop. Next, the body will oscillate about the lowest point if its velocity at lowest point is less than 2gr. So body will oscillate about the lowest point if its velocity at the lowest point is less than 2gr. So to leave the loop, that is the meaning. Now, means to continue its circular motion, the minimum velocity required is, it lies between root 5gr and root 2gr. That point is given here. The string becomes slack and fails to describe the circular motion. Its velocity is at lowest point lies between these two. So if it lies between these two, it leaves the path. Means to leave the loop of the circle, and this is the condition. So it lies between these two. If velocity lies between these two values, it will not continue in the path. It will oscillate at the lowest point if velocity is less than 2gr. Yes. So keep these points in mind. To continue its circular path, at lowest point, it should be greater than 5gr and it should be less than 2gr. If the value lies between them, it leaves the loop. Next one is, our next concept is motion in a horizontal circle. Means conical pendulum. Conical pendulum describes the horizontal circular motion. Here, now the bob is rotating, describing for the string, bob is connected. This is the bob, mass m. It is describing horizontal circular motion. So we are link that bob at the bottom of that string. Then it describes horizontal circle. And you can see the terms related to this free body diagram. O is the center of the circle. When it is at a point B, these are the components of forces. Weight will act downwards. And this creates tension along the string. Now this tension, as it is making theta with the vertical, here also angle is theta. So tension resolve into its components. T cos theta and T sin theta will be towards the center. So for the condition of equilibrium, we just balance the forces vertically and horizontally. That is, T cos theta is balanced with mg and T sin theta is balanced with mv square by r, which is the force, centrifugal force, which acts radially outwards, equal in magnitude of centripetal force. And in the diagram, SP is nothing but length of the string and OP is the radius of the circle. These two, 1 and 2 equations, if you divide sin theta by cos theta, then tan theta is equal to V square by Rg. And if you square and add 1 whole square plus 2 whole square, we get the tension. So 2 by 1 is giving V square by Rg. And tension along the string will be equal to mg into under root of 1 plus v power 4 by r square g square. Because here we are finding tension along the string by squaring and adding the first and second equation. And the time period of the revolution, as the bob is oscillating while describing the horizontal circle, we can ask the time period of the oscillation. So here to find the time period, first we need to find the angular speed of that bob, which is describing the horizontal circle. So for that, I am taking this equation. From this equation, let me write from this equation v square is equal to rg tan theta, v is equal to root rg tan theta. And we know that in a circle v is equal to r omega. So from this, omega is equal to r by v. And v is rg tan theta. This gives omega is equal to under root rg tan theta by r square. I am writing inside the root. Omega is being equal to v by r. Yes. Now r is taken under the root, it will be r square. So omega is equal to now g tan theta by r. And from the figure, if you take from this triangle SOP, we can write tan theta will be equal to opposite. Here this is r, opposite side is r by adjacent. So tan theta is being equal to r by h. So if we substitute, therefore omega, substitute tan theta is r by h, then omega we will get it as like g by h. And the time period, to find the time period of revolution, we have equation from the circular motion 2 pi by omega. So now you can look at the above equation. Now t will become 2 pi into like 1 by omega, which is under root of h by g. And in the figure, h is equal to L cos theta. From SOP, h is equal to L cos theta. So time period of the revolution becomes 2 pi into under root of L cos theta by g. So when it describes a horizontal circle, tension along the string is this much, and time period of the revolution is this much. If they're asking angular speed, we can use this one, omega equal to under root of g by h. And what is the speed? It is given at the point P to continue the further motion, means under root rg tan theta. Now, let us see the car moving on a level road, on a banked road. So it is under the case of circular motion. So the case of a cyclist. Here we are given with the free body diagram. The cyclist is moving in a vertical circle. You can see this is the curve of the circle. To safely negotiate a curve of radius r, a cyclist should bend at an angle theta with the vertical. So while moving along that curve, the cyclist should need to bend with some angle. So what is that angle means? You can see here. Now the cyclist will be at this position. So N will be the resultant reaction force which is making angle theta with the vertical. So it will be N cos theta and N sin theta. So which is given by tan theta is equal to V squared by RG. Actually, it is making angle theta with the vertical while describing the horizontal circle. The cyclist is moving along the curve of radius r. Okay, now n sin theta is acting towards the center of the circle. So to find that angle of banking or angle made with the vertical is tan theta is equal to V square by Rg. Here theta is also called as angle of banking. So towards the center n sin theta, which experience the center of the circle mv square by r. So this is a case of cyclist related to the horizontal circular motion. So towards the center of the circle mv square by r, and n cos theta will be balanced by weight of that cyclist. From these two only we given that banking angle is the tangent of banking angle is equal to V square by Rg. So what is the maximum speed he needs to maintain means here we can give Rg tan theta. Now let us see case of a car on a level road. So now car is on a circular track. The track is a level track. So I just give the free body diagram. This is the circular track and the car is moving in the circular track. This is the path followed by the car. And let us see here the free body diagram of that vehicle. Let us take this is the vehicle, means weight upward. It acts upward. And without skidding, a weight of the body or vehicle will act downward. Normal reaction will be upward. Reaction force is upward. And this direction towards the center to support that motion without skidding towards the center of the circle, frictional force develops, maximum frictional force develops. Now, this frictional force will experience the centripetal force which acts towards the center of the circle. On that level track, circular track, what is the maximum speed he needs to maintain that we are going to find. Then frictional force is always proportional to normal reaction. Then maximum frictional value is mu into n. So take here mu n is equal to mv square by r, where v is the maximum speed needs to maintain. So when he is on a level track, on a circular track level road, what is his safest speed needs to maintain. And n is balanced by, in this free body diagram, normal reaction and weight of the car downwards. So reaction force is balanced by mg. So mu mg is equal to mv square by r. So m cancel. So the maximum static friction or coefficient of static friction should be greater than or equal to v square by rg. You can observe in the diagram, you can observe this equation. What is the static friction, coefficient of static friction between the tires of car and the level track is greater than or equal to v square by rg. So from this we can write the maximum safest speed is mu rg. So this is the maximum speed he needs to maintain without sliding towards the center of the track. This is the case on a level road. And let us see case of a banking of road. Banking of road, and it is frictionless, no friction. Banking of road means there is a difference in inner and upper layer of the road. It is a little raises up, making angle theta with the horizontal. There is angle of inclination. So here, when vehicle is on that banking of road, on that banked road, this is the free body diagram. Here we are given with the forces. So when the banked surface is smooth, no friction, friction will be zero. So the forces acting will be gravity and normal force only. So weight will act downwards, normal reaction will be perpendicular to surface of contact of car and road and towards the center of the circle mv square by r. So now balancing forces for the condition of equilibrium, n cos theta means this weight force resolve into components like mg cos theta, and in this direction like mg sin theta. So n cos theta is balanced by mg and n sin theta is balanced by okay. Here normal reaction force is resolving into its components because there is no friction. So let us visualize the normal reaction force. Means we are extending normal reaction making angle theta with the vertical now. This is n cos theta. Now this direction will be n sin theta. Means like a towards the center, that much force will act. So it experiences the centripetal force which is mv square by r. So n cos theta equal to mg, n sin theta is equal to mv square by r. So from this tan theta is equal to v square rg. So when there is no friction, v is equal to rg tan theta. So this is the safest speed he needs to maintain, but without friction, it can tear the parts of the vehicle. On smooth roads where there is no friction, with this speed, it can tear the parts of the vehicle. Now, case of banking of road with friction. So we can observe in this diagram, let velocity of the vehicle be v. Now, when v is maximum, the frictional force will be acting down the slope. So if he is maintaining the maximum safest speed, when vehicle possesses the tendency to skid up the plane, the vehicle is moving up the plane, the frictional force will be acting down the slope. So now you can see in the picture by extending this line, and normal reaction is making angle theta. So this is n cos theta, and this will be n sin theta. So now here the frictional force which is acting down the plane is also making, means actually frictional force is in this direction. I can say here angle is theta. Then Adjacent side will be like f cos theta and opposite side will be f sin theta. You can see the free body diagram here also. So now to find the maximum safe speed, we have to take the balancing forces on the vehicle at that point, at the equilibrium point. So let me take, you can see here, n sin theta plus f cos theta will act towards the center and they experience the magnitude of force mv squared by r. So n sin theta plus f cos theta will be equal to mv squared by r. Next, n cos theta minus f sin theta will be balanced by the weight of the vehicle. So by simplifying these two from 1 and 2, you can find the maximum safest speed which velocity can, which the vehicle can safely negotiate a curve of radius r on a rough incline road. So this is the maximum safest speed need to maintain. By solving 1 and 2 equations, we get this equation. Rg into mu plus tan theta by 1 minus mu tan theta. So on banked road with friction, this is the maximum safest speed when the vehicle have the tendency to move up the plane. So in hill stations, the vehicle moving up the hill, we need to maintain this maximum safest speed. Next, we can see in case of minimum velocity with which body could move in a circular motion. So it is also banked road only. So when the vehicle has the tendency to move down the plane, so while traveling down the hill station, so down the plane, friction will act opposite to that direction of the vehicle. Now friction will act up the plane. So here also we can resolve normal reaction force in this side n cos theta and towards that center there will be n sin theta. And now frictional force here it is making with this horizontal theta. So along mv square by r there is f cos theta and opposite is this line, opposite angle, friction making angle theta with the horizontal direction. So f cos theta, it will be f sin theta, opposite to angle will be. So for the condition of equilibrium, we can balance the forces horizontally and vertically. That is n sin theta minus f cos theta, you can see, will be equal to, they experience the magnitude of force mv square by r, this resultant force. So these are horizontal forces. Now vertical forces, balance the vertical forces. Now n cos theta plus f sin theta is equal to mg. So solving these two equations, we can get the minimum speed when the vehicle has the tendency to move down the plane. It needs to maintain this much minimum speed, that is Rg into mu minus tan theta by 1 plus mu tan theta. So students, while if you're buying any course from the Spark Academy, enter this coupon code SAN10. By using this, you will get the discount. So let us go to the previous year's questions. Here we are given with the first question. A mass M is revolving in a vertical circle at the end of a string of length 20 centimeters. By how much does the tension of a string at the lowest point exceed the tension at the topmost point? So in previous question, in the previous slide, we have seen already what is the tension at point A minus the tension at point B. Means we can see by comparing the equation. Yes, this slide. Lowest point exceeds the tension at the topmost point. See, you can see TA minus TC. A is the lowest point, C is the topmost point. TA minus TC is being equal to 6 mg. So this much we have proved. So we are taking these equations, T at A and T at C. So you must take the tension at the lowest point and tension at the highest point. So in the previous slide, in that circle, tension at A minus tension at C is equal to how much? That we need to find. So tension at A means tension at the top of at the bottom of the circle is equal to M. Let me take like V2 square, the speed at that point, and the length is given as like 20 centimeters, 20 plus mg. This is the tension at the bottom, means at A. Next, tension at the top. So we are taking velocity at the top is like V1 square, and the length of the string is given 20. Here minus, because it is minimum. At the top, tension will be minimum, like it is at C. And if we are taking TA minus TC, these two equations, we get it as like mv2 square minus mv1 square by 20 plus 2 mg. We are subtracting, so these two will become 2 mg. And we know that velocity at the topmost point will be equal to velocity at the bottom square minus 2gh. Of course, h is like L cos theta. Now here, first we need to find what is that h. H is L into 1 minus cos theta. So it will be equal to L is 20 into 1 minus top to bottom angle will be 180. We get it as like 2. So it is 40. So we can find velocity at the bottom square minus, it will be h value 40, it is 80g. So from this we can write Vc square or Va square minus Vc square is equal to it will be equal to 80G. So substitute that value. VA square minus VC square is nothing but V2 square minus V1 square. I consider at bottom at A velocity V2, at the top means at C velocity V1. So we can write here m into V2 square minus V1 square is 80G by 20 plus 2mg. 20 4s are 4mg plus 2mg, 6mg. So we have proved. So in the concept, TA minus TC is being equal to 6mg. Next question. The string of a pendulum is horizontal. The mass of the bob is m. Now the string is released. What is the tension in the string in the lowest position? First, it is like horizontal from O. It is being like horizontal. Now it is released. So now this is the lowest path of the pendulum, lowest position of the pendulum when it is released. So according to law of conservation of energy, it is horizontal, it is lowest. So total energy at horizontal is equal to total energy at lowest position. And this is the length of the string. And this is also length of the string. So we can write like mg because it is at that height when it is at a horizontal position. So I can write mgl. Total energy at h is only potential energy. When it is at L, it can have some velocity. So it is given with velocity to make the circular motion. So we can write half mv square. So from this we can find what is v or v square value, which is equal to 2gl. Now they are asking tension. So at this point, weight will act downwards, tension will be upward. So P minus mg will experience the centripetal force mv square by r. So take this as equation 1 and equation 2. Substitute v square value here, it gives P is equal to 3mg. That is the answer. Next question. How fast can a car travel around an unbanked curve with a radius 60 meters if the coefficient of friction is 0.40? It is the question about circular track level road. So what is the speed means we can take, whereas mu is almost greater than v square by rg, then v is equal to mu rg. So we can find mu value is 0.4, radius is 60 meters into 9.8. That will be the answer. So students, you can try, this is a required discussion today about the cases of circular motion. By using concepts, you can find the solutions. Thank you, students. Be in touch for the regular updates. You can join for the regular updates. Thank you.